The world is transforming faster than we could have ever imagined. Every day, we are witnessing new innovations that make us more advanced. And at the heart of this exponential growth and urbanization is energy efficiency. Aiding this growth through seamless distribution of electricity, empowering millions and making us more energy efficient, is Schneider Electric transformers. Transformers that are a result of breakthrough innovations, in-depth research, superior technologies, and draw strength from its global synergy. A legacy which is inherent in its range of world-class transformers. Schneider Electric decided to converge its 65 years of experience in design, development and manufacturing of distribution and power transformers in India by creating a state-of-the-art factory with a capacity of 10,000 MVA, backed by research, a skilled team of more than 500 engineers and stringent quality control. Being located in Vadodara, Gujarat and very close to the port makes this factory a commercially viable hotspot for exports.
Erection, commissioning and testing of transformers requires great deal of planning and arrangement of resources. It is essential to have erection agency with skilled manpower, having experience of EHV class power transformer. Each and every unit is to be treated like a project, so that cost, quality and time are controlled and monitored through a process. It will ensure that erection activities are carried uninterrupted with safety and without any damage to transformer parts or items. It is suggested to have kick-off meeting KOM with following main agenda: competency of erection agency and their manpower skills, to confirm receipt of transformer as per BOQ in full shade, to confirm availability of TNT as per requirement of unit, size and rating. Refer list as per this manual. To confirm readiness of plinth and radiator foundation as per requirement. Physical check of dimensions. To confirm overhead conductor takeoff or power cable terminations arrangement as the case may be. To confirm safety measures adopted and location hazards, if any. Organization reporting structure, data recording, responsibility and clearances. To confirm insurance, workman compensation and labor-related statutory requirements. Comply to specific requirements agreed in design review. Safety measures and precautions. Keep recommended fire extinguishers at site. During hot oil circulation, keep fire extinguisher ready near transformer. Carry out all pre-commissioning testing and final commissioning check as elaborated in this manual before energizing transformer. Take precaution while handling PRB devices having heavy springs in compression to safeguard person and system. Replace N2 fill tank by breathable dry air of dew point less than -40 OC at least for 24 hours. Provide adequately rated cables and fuses. Never apply voltage when transformer is under vacuum. Oil slippage shall be inspected regularly and attended if any. Oil shall not allow to fall on ground. Keep all combustible items away at safe distance to reduce risk of fire. Welding on oil-filled transformer may be avoided or done as per instruction of manufacturer only. All erection personnel must use personal protective equipments like helmet, safety shoe, boiler suit, etc. No welding work shall take up near transformer. Electrical equipment like filter machine, dry air generator, etc. must be earthed. First aid box shall be kept ready at site. Adequate lighting must be available for clear visibility. Cordon off the working area, particularly when transformer augmentation work in a switchyard is taken up. All major erection activity like bushing, conservator and radiators must be carried out with the crane of adequate capacity and boom size. Never carry out work with unskilled workers. Safety posters like no smoking, wear helmet, etc. must be displayed. Testing circuit and procedures are important to follow as per manual to avoid any induction effect before and after the test. Approved and tested earth rods are essential for this purpose. Safety nodal officer to make sure that site is cleared on daily basis to prevent fire hazards. Pre-commissioning tests. Preparation of SAT, Site Acceptance Test. Site duty. Collection of factory acceptance test reports. Finalization of action plan of carrying out SAT. Prepare testing program schedule. Check whether the transformer under test had been isolated from other electrical equipments and from induction using earth switch or local earthing arrangement. Ensure for all safety assessments of helmets, gloves and safety shoes. Execute the test according to the program schedule. Compile the test reports. Do analysis of the test results and ensure of healthiness of transformers. Following checks should be carried out before commencing the pre-commissioning test of the power transformer. Ensure that transformer and its auxiliaries should be free from visible defects on physical inspection. Ensure that all fittings should be as per outline general arrangement drawing. Ensure that bushings should be clean and free from physical damages and ensure that oil level is correct in all bushings. Ensure that oil level in main OLTC conservator tank in MOG is as desired. Ensure gearbox oil level in OLTC. Ensure that OTI and WTI pockets are filled with transformer oil. Ensure that cap in the tan delta measurement point in the bushing is grounded. Ensure unused secondary cores of bushing CTs, if any, has been shorted. Ensure CT secondary star point has been formed properly and grounded at one end only as per scheme. Ensure that Bushings relay is correctly mounted with arrow pointing towards conservator. Ensure all power and control cable terminals are tightened. Ensure all cables and ferules are provided with number as per cable schedule. Ensure that external cabling from junction box to relay control panel is completed. Ensure operation of OLTC manually, electrically and local and electrically by RTCC. Ensure indication of tap position on diverter switch. Drive mechanism and RTCC are same. Ensure working of numerical AVR. Bushing and current transformers. Bushing for voltage less than or equal to 36 kV class are proclean bushing but based on customer requirements, but these can also be of the OIP type. For voltages above 36 kV, these are the OIP type, oil impregnated paper. High current low voltage connections for core coil assemblies are made with copper bus bars, which are connected to the bushing by means of flexible risers. The terminations can be either on cover plate or on the side of the tank. These can be housed in special cable boxes as per requirement. Any special required current transformer are housed either in separate turrets or on the cover plate or as part of the core coil assembly. The secondary circuits of the current transformers are brought out in the separate terminal boxes. from where the secondary is wired in the marshalling box. The current transformer can either be for protection or for monitoring, for emitters and temperature indicators. OIP bushing fitting. The oil-impregnated paper insulated bushings are used to connect overhead lines to transformers. These are mounted on transformers in vertical or inclined position at a maximum insulation of 30 degrees from the vertical. The condenser body is enclosed in a weather-resistant housing consisting of top expansion chamber, an upper proclean, a welded flange, ground sleeve assembly, a lower proclean and bottom gap. The annular space between the condenser body and the housing is filled with pure transformer oil. A disc spring assembly located in the top housing holds all synthetic rubber gaskets and O-rings between proclean and metal parts under controlled pressure. Completely scaling the bushing, an oil sight window is provided on the expansion chamber for observing the oil level. The space in the expansion chamber above oil is filled with dry nitrogen gas. Due to these genetic sealings, the bushing are maintained free and non-susceptible to aging. Brown glazed proclean insulators of high strength are used as air end and oil end insulators. Air end proclean is normally provided with a nominal top creep age length of 25 mm per kV of the rated voltage. Oil end proclean is cone shaped without shells. Air end proclean is provided with alternating long and short shells. Packaging and storage of OIP bushing. To prevent physical damage to the bushings, generally only one bushing is packed in one case of wooden case. The bushing is placed in the packing case at an angle of 6 to 8 degrees to horizontal. Accessories like arcing horns, terminals, etc. are also packed in the same packing case. This is to ensure the remains immersed in oil. When the packed bushings are stored outdoors, they should be kept horizontal and covered with tarpaulin for protection from rain and other atmospheric contaminants. Conservator tank with oil drain, filling, fitting hole, valves. This is a cylindrical tank mounted on supporting structure on the roof, the transformer main tank. The main function of conservator tank of transformer is to provide adequate space for expansion of oil inside the transformer. When transformer is loaded and when ambient temperature rises, the volume of oil inside transformer increases. A conservator tank of transformer provides adequate space to the expanded transformer oil. It also acts as a reservoir for transformer insulating oil. This is a cylindrical shaped oil container closed from both ends. One large inspection cover is provided on either side of the container to facilitate maintenance and cleaning inside of the conservator. Conservator pipe, that is, pipe comes from a main transformer tank, is projected inside the conservator from bottom portion. Head of the conservator pipe inside the conservator is provided with a cap. This pipe is projected as well as provided with a cap because this design prevents oil sludge and sediment to enter into main tank from conservator. Generally, silica gel breathing fixing pipe enters into the conservator from top. If it enters from bottom, it should be projected well above the level of oil inside the conservator. The arrangement ensures that oil does not enter the silica gel breather even at the highest operating level. MOLG and POLG, magnetic oil level gauge and prismatic oil level gauge fitting. MOLG shows the level of the oil in the conservator tank through the needle as a clock, and it's connected through a float that is moving inside the conservator tank, and it moves accordingly. And it moves according to the level increase or decrease in the conservator. Mounting of MOLG is being done through suitable size of oil seal, gasket, hardwares, and tightening is done as per prescribed torque. It has 1 or 2 set of contacts for alarm or trip circuit. Plain oil level gauge indicates oil level in tank or conservator. Window opening is fitted with grooved Perpex sheet and metal frame to give clear indication of oil level. This gives a clear visible indication of the oil level in the conservator. It is normal practice to use magnetic oil level gauge with low level alarm and trip contacts. This can also be of the plain glass or prismatic type. The oil level gauge is marked to indicate minimum, normal and maximum oil levels in the conservator as a function of conservator capacity. The conservator or partition for an on-load tap changer carries its own oil level gauge. For bigger units, it is our standard practice to fit a normal oil level gauge on the tank also. POLG is prismatic oil level gauge made with glass to display the oil level in the conservator tank. Fitting of this glass is very simple with gasket, hardwares and steel support with maximum, minimum or normal. Marking on this steel frame, this is an additional device to monitoring the oil level in the transformer. To monitor the oil level in the transformers. This is a Bushings relay. Presently I am removing the terminal cover. Now in the terminal box, upper side having 0 to NOS terminals for alarm circuit connection and bottom 0 to NOS terminals for trip circuit connection. If you see the glass window of the Bushings relay, there is a scale having 200, 300 or 130 NOS. It is showing gas volume. On the top, it is engraved Conservator. with a direction arrow. Forward direction of arrow directs conservator pipe connection. End of the arrow showing transformer tank side pipe connection. On the top of the Bushings relay, there are 02 petcock valves. Right side is for air venting and left side is for test vent of Bushings relay. We can compress air from left side valve and check the operation of Bushings relay. In the bottom, there is a plug arrangement. This used for draining the oil from Bushings relay. There are 3 provisions of cable glanding arrangement: left, right and bottom. We can use any of them. Only use glanding point of blanking should be removed before commissioning. There is a locking and key arrangement inside the terminal box, and there is a slot in the key. If the slot is towards the S, it means Bushings relay is in service position, and if it is on the transport lock TL position, it means Bushings relay is in lock position. In transport lock position, alarm and trip both will show continuity. In service position, alarm and trip both will not show continuity. We can test the Bushings relay without applying any compressed air. There is a red color pointer located to S position. When the key lock slot moves to S position, when the key lock slot moves to TL position, red pointer move to TL position. In TL position, it is showing continuity in both alarm and trip circuits. Now in this way, we can check the function of Bushings relay at side. Radiator butterfly valve fitting. Butterfly valves provides flow path to the TRF, oil for cooling purpose during the service condition of the transformer. Normally it is closed during transportation or storage of transformer. There are 2 modes in this butterfly valve, that is open and shut. At the time of the radiator fitting, oil fitting and TRF in service condition, it is in open mode as per arrow mark. Radiators fitting. Special care should be taken while removing radiators from crates, and the same care should be taken during handling and mounting the radiator bank. This is because any minor damage can initiate oil leakage from the bank. As radiator units are made from very thin steel sheets of metal for good conduction of heat from oil to air. After removing from crates, these radiators must be cleaned externally. These are also required to be cleaned from inside by flashing with transformer insulating oil. The radiator units must be assembled one by one. That means fitting and fixing of one unit must be completed in all respect before assembling the next unit. The assembling should be started from one side and finished at the other side. Before assembling the unit, remove blanketing plates from the top and bottom radiator valves. During the removing of the blanketing plates, if gasket surface is damaged, it should be replaced by new gasket. Then the radiator unit would be lifted vertically and brought nearer to the respective main tank valves. Now remove the blanketing plates of the main tank valves. Fit the radiator flange on respective valve of main tank by nuts, bolts, plane and spring washers. Assemble all the other radiator units in the same manner. When an electric transformer is loaded, the current starts flowing through its windings. Due to this flow of electric current, heat is produced in the windings. This heat ultimately rises the temperature of the transformer oil. We know that the rating of any electrical equipment depends upon its allowable temperature rise limit. Hence, if the temperature rise of the transformer insulating oil is controlled, the capacity or rating of transformer can be extended up to significant range. The radiator of transformer accelerates the cooling rate of transformer. Thus, it plays a vital role in increasing loading capacity of a transformer. This is basic function of a radiator of an electrical power transformer. The working principle of radiator is very simple. It increases the surface area for dissipating heat of the oil. In case of electrical power transformer, due to the transport limitation, these units are sent separately and assembled at site with transformer main body. At the time of dispatching, the flings of radiator are blanketed by gasket and blanketing plates. The radiator valves on the main tank are also blanketed by gasket and blanketing plates. Under loaded condition, warm oil increases in volume and comes to the upper portion of the main tank. Then this oil enters in the radiator through top valve and cools down by dissipating heat through the thin radiator valve. This cold oil comes back to the main tank through the bottom radiator valve. The cycle is repeated continuously till the load is connected to the transformer. Dissipation of heat in the transformer radiator can be accelerated further by forced air provided by means of fans. These fans are fitted either on the radiator bank itself or fitted nearby the bank, but all the fans must be faced towards the radiator. Sometimes the cooling rate of convectional circulation of oil is not sufficient. That time, an oil pump may be used for speeding up oil circulation. cable box. Cable box provision is generally provided in indoor type of transformer. Purpose of mounting of cable box is to provide enclosed to the transformer level terminals and to prevent any damages mishappening from foreign particles. There is a cable entry gland plate in the bottom of the cable box and chopper bus bar with flexible on upper side of this cable box to facilitate termination of cables and mechanical support also. Sudden Pressure Relay (SPR). This is Rapid Pressure Relay. These are the connections in the RPA. We call it standard connection. If it is vertical mounting type, it will be mentioned on the direction plate of this relay. Here it is vertical type RPR. It will be mounted on the transformer tank in vertical position. You can see other one is horizontal type and it will be mounted vertically on the transformer tank as displayed on the direction plate. And cap will be fitted horizontal like this. So to recognize horizontal, this cap will be horizontal, and for vertical, cap will be vertical. It is vertical mounting air plug. Air mounting on the transformer tank, this nameplate and seal. Serial number is mentioned here. Don't open the seal. This is a cover to protect the terminal connection. At the time of wiring, remove the cover and connect the control cable. At bottom, there is also a cover. Remove it before mounting by using ring gasket. There is cable gland which will fit in the terminal connection. It is a standard connection type and it is ANSI connection. In ANSI connection, it is white color nylon, and in standard connection, this is rubber type projection. We are opening cable gland. There are 3 pins and 1 rectangular slot in both portions. By matching rectangular slot, we fit the cable gland by tightening the outer portion properly. Pressure Relief Valve (PRV). This is 6-inch PRV. When you remove from box, you will get 6-inch mounting ring or gasket. There are 6 mounting holes. When we mount it, the fasteners will be tightened diagonally. On the top of the PRV, there is a red flag. When it goes up, it means PRV is operated. This is pushing the flag to go up. For resetting, put the flag down. It will reset after that. There is no micro switch. One no contact and other NC contact. When red flag is down position, no and NC contacts actuated. But when the red flag is up, at that time no becomes NC and NC becomes no. Please notice serial number and pressure mentioned on the nameplate. Don't put any lubricant inside the PRV. Air cell fitting. The air cell fitting. The air cell flexible separator is fitted inside a conservator tank, isolating insulation oil from the atmosphere and thus preventing contamination of gas and/or moisture from coming in contact with the transformer oil due to oxidation and hydrolysis. The bag is vented on the transformer through flange type mounting such that it inflates or deflates to accommodate oil volume displacements due to change in the transformer temperature. The air cells are manufactured using time-tested combination of nylon fabric and thick coating of elastomers, acrylonitrile butanate rubber, polychloropyrene and hypalon (CSM). The rubber compounds are so formulated so as to minimize separator degradation and resist leakage of air through membranes, thus reducing the amount of air in the transformer oil. Over a period of time, this air or gas can be reduced dielectric strength and thereby accelerate the aging of the insulation system. The advantages of the air cell can be well concluded from the facts. Simple design with no expendable parts needs negligible man-hours for inspection. Extended service life. Economical prevents corrosion. Oil can be filled into the transformer tank without being exposed to the air. Since insulating oil is completely isolated from the atmosphere by an air cell, there is no possibility of oxygen or moisture penetrating the oil. Pressure of the surface of the oil is constantly maintained at the atmospheric pressure, offering no possibility of the oil becoming supersaturated and forming bubbles. Thus, high dielectric strength can be maintained. Connecting flange, pipe connecting breather, straps, Zena cell or air cell, conservator, oil level indicator, float arm, float. Simple design with no expandable parts, needs negligible man-hours for inspection, extended service life, economical, prevents corrosion. Oil can be filled into the transformer tank without being exposed to the air. Since insulation oil is completely isolated from the atmosphere by an air cell, there is no possibility of oxygen or moisture penetrating the oil. Pressure on the surface of the oil is constantly maintained at the atmospheric pressure, offering no possibility of oil becoming supersaturated and forming bubbles. Thus, dielectric strength can be maintained. Mounting of Silica Gel Breeder. Whenever electrical power transformer is loaded, the temperature of the transformer insulating oil increases. Consequently, the volume of the oil is increased. As the volume of the oil is increased, the air above the oil level in conservator will come out. Again, at low oil temperature, the volume of the oil is decreased, which causes the volume of the oil to be decreased, which again causes air to enter the conservator tank. The natural air always consists of more or less moisture in it. This moisture can be mixed up with oil if it is allowed to enter into the transformer. The air moisture should be resisted during entering of the air into the transformer because moisture is very harmful for transformer insulation. A silica gel breather is the most commonly used way of filtering air from moisture. Silica gel breather for transformer is connected with the conservator tank by the means of breathing pipe. The silica gel breather or transformer is very simple in the aspect of design. It is nothing but a pot of silica gel through which air passes during breathing of transformer. The silica gel is a very good absorber of moisture. Freshly regenerated gel is very efficient. It may dry down air below 40 degrees centigrade. A well-maintained silica gel breather will generally operate with a dew point of 35 degrees centigrade as long as large enough quantity of gel has been used. This picture shows a silica gel breather of transformer. Silica gel crystal has tremendous capacity of absorbing moisture. When air passes through these crystals in the breather, the moisture of the air is absorbed by them. Therefore, the air reaches to the conservator is quite dry. The dust particles in the air get trapped by the oil in the oil seal cup. The oil in the oil sealing cup acts as barrier between silica gel crystal and air when there is no flow of air through silica gel breather. The color of silica gel crystal is dark blue, but when it absorbs moisture, it becomes pink. When there is sufficient difference between the air inside the conservator and the outside air, the oil level into two components of the oil seal changes until the lower oil level just reaches the rim of the inverted cup. The air then moves from high pressure compartment to the low pressure compartment of the oil seal. Both of these happen when the oil acts as core filter and removes the dust from the outside air. Marshalling box. As the name implies, this is the master control panel for the protection devices. This is a panel with a door part of which is with glass, allowing easy visibility of the instruments and their readings. This houses indicating instruments. In addition, all the secondary wiring of the transformer from current transformers, relays, oil level gauge, OTI, WTI, cooling fans, etc. are terminated on the terminal blocks, from which cables can be taken to the supply and control connections. The necessary control switches, contactors, etc. are housed in this cabinet. The cabinet may be provided with heating and anti-condensation facility. The cabinet has a ventilation facility which is protected against insect entry. oil and winding temperature indicators. Check the box for any damages. Cut open the band and tapes using a cutter. Each instrument comes with individual test certificates and manuals. Please refer them during installation. Remove this document and file from them for future reference. Slip one finger at the edge and remove the foam packing. These are environment friendly. Check for any possible damages to the instrument itself. Check the ambient temperature. Always handle the instrument holding its head. Unpacking the instrument. Important. Do not bend the armor in sharp bends. The bend radius must not be less than 3 inches. Preliminary test procedure. Lifting the instrument by the head, mounted vertically on a stand like this. The armor must be cold and left down. Unscrew the bolt fixing the union and remove the union from the sensing bulb. Note the mark on the sensing bulb. Ensure that the bulb is fully immersed till the mark minimum 130 mm. Align the red maximum pointer needle thus to match with the indicator pointer. Wait until the oil bath stabilizes at the selected temperature. Once temperature is stabilized, check the corresponding temperature in the instrument. Always stand in the front of the instrument while taking reading. Move the maximum pointer for better clarity. Similarly, set both at any other temperature to test. After 5 minutes, check reading in instrument. Switch setting procedure. Unscrew the cam corresponding to the switch you want to set. The screw turns anti-clockwise. Once cam is loosened, push it upwards to select temperature on the switch scale. Once done, tighten the screw to set it at chosen temperature. Repeat process for any or all other switches. Check switch operation manually by moving the indicating pointer up to and back from the set temperature. Switch testing procedure. Remove the top case. Just unscrew the nuts on the 4 sides in rotation. Always store the top case's glass side up. Terminal connection for switch testing. You will need continuity tester, screwdriver, oil bath and a small container of cold water. Check the wiring diagram inside the top case for switch connections. Insert the sensing bulb halfway, that is, let only the tip of the bulb. Check the temperature raising gradually in the instrument. The LED will turn on at the switch set temperature. Note, this is the switch on reading. To test the switch differential, cool down the sensing bulb. Dipping the sensor in cool water will reduce the temperature faster. Once the LED is off, check the reading on the instrument. This is the switch off reading. Switch differential on reading, off reading. Check this differential to the instrument test, certification for verification. Gradient testing procedure for WTIs. Set the oil bath to 60 centigrade and insert the sensing bulb fully. Connect the leads to the corresponding blue terminals number 9 and 11. Check the wiring diagram for the connection details. Fix the top case of the instrument back on. Make sure all the 4 screws are tightened fully. Connect the other ends of the leads to a current source. Set the source to the required current amps. The current must be passed for at least 40 minutes. After 40 minutes, check the reading in the instrument. The reading will be bath temperature plus raise due to the current passed. Minimum adjustment procedure. If the ambient temperature is not correct, follow the below instruction. Set oil bath at 40 degrees centigrade and insert the sensing bulb into the bath. Wait for 5 minutes and then check the reading. If instrument reading is not within accuracy, then follow this procedure. Remove the top case and store it glass side up. This is the lock nut top and hollow stud bottom for the zero adjustment. Use one spanner to hold the lower nut and the other spanner to loosen the upper nut. Turn upper nut to the left, that is, away from the pointer. Now, to adjust the indicating pointer, use the spanner to turn the lower nut to the left. See the indicating pointer moving to the right, that is, increasing the reading. If you want to decrease the reading, move the lower nut to the right. Once the pointer reaches 40 degrees centigrade, lock the upper nut, hold the lower nut and tighten the upper nut. This time, turn the upper lock nut to the right, that is towards the indicating pointer. Ensure that the lower nut does not move while locking the upper lock nut. Once done, check reading and match to the oil bath. Also check for the spring action of the pointer. Remote Tap Changer Control Cubicle (RTCC), an indoor panel which main objective is to control the transformer's tap changer from remote. This panel houses, among others, an AVR, automatic voltage regulator, which can be utilized to regulate transformer voltage using principles such as master flower method or circulating current method. Approved numerical protection relays, selected the best quality and latest technology in its design. Panels are fitted with anti-condensation heater and thermostat, also with door-operated lighting. Remote control operation are used for panel that involve with high voltage equipments and protective system to protect the equipment and for electrical installations. All of the panel undergo factory testing that accentuate safety, quality and functionality. AVR EE301M Demonstration of Automatic Voltage Regulating Relay EE301M. Now you can see the front panel of regulating relay. There is one power on-off switch. For voltage display, 4-digit display. For command indication, LEDs are there. For set mode, there are 3 pot and 1 selector switch. For the delay set, there is a set pot for setting. For auxiliary and PT protection, auxiliary and PT fuses are available. For test or nominal operation, there is 1 switch and knob. This is real panel of regulating relay. There is a terminal station for connection and the details of terminals are provided on rear panel nameplate. On the nameplate, auxiliary supply voltage and weightage are mentioned. It is also described the pin number of terminal station for the necessary circuit. Pin number 1 and 2 are auxiliary input. 3 and 4 for PT connection. 9 and 10 for LR. And 11 and 12 for RR, 13-14 for UV, and 15-16 for optional contacts. We have provided 110 volt supply to the terminal 1 and 2. Because this is 110 volt auxiliary supply relay, we connect the PT terminal 3 and 4 to a variac of dimmer-stat. Through this, we can regulate the PT voltage for operation check on regulating relay. Here on pin number 13 and 14 for regulating relay output pulse connected with a continuity tester. Where we get regulating relay pulse, we observe continuity indication. Now we switch on the unit. We can see the voltage display. This is PT voltage as selector pot in PT input direction. Now selector switch is in PT input direction. It means the display will show PT input voltage only. Now we check the setting. For setting, first of all we have to set nominal set. For this, nominal set pot is provided. Then we keep the selector in nominal set position. Now the display showing nominal voltage. Presently nominal voltage is 110 volts by default. Range of nominal voltage is plus minus 10% by moving the nominal setting pot variation of voltage display observed. R setting and L setting can be done only after nominal setting. Because R set and L set will change with the change of nominal set. Now we are checking R set. Factory set by default is 105 volt at range of 0.5 to 5 volts against nominal set. We will keep R set at 105 volts. Similarly, L setting can be done. L set setting is 0.5 to 5 volts. Above nominal voltage setting by default, it is 115 volts. After 3 setting, we have to set time delay setting. We can see the time delay setting for 10 seconds to 120 seconds. This time, delay operates when PT voltage beyond the band voltage, then time relay operates to delayed RR and LR. This time, delay setting should be more than the each tap change operation cycle time on on-load tap changer. Now we will see the operation of RR. Now we will change the PT voltage and see the actual operation of regulating relay. Now we can change the RR at less than 105 volts. RR pulse will display and continuity light will glow in between pin number 13 and 14. Similarly, when we change LR pot set time to more than 115 volts, LR pulse LED will display and continuity will glow after 10 seconds. Display in between pin number 1 and 12. When the PT voltage 80% of the nominal PT voltage, it will glow under voltage UV LED light. AVRR will be in normal operation when PT voltage restored to 85% of the nominal voltage.